Topic of the lecture: physiological and pathological types of occlusion. First of all, I would like to remind you about how develop human's body in utero.
The facial features of the human embryo develop rapidly very early on in pregnancy, beginning around the 4th week after conception. Many of the structures of the face originate from a group of cells called cranial neural crest cells. These cells move in a distinct pattern from the neural tube located in the back of the embryo to create the various structures of the face. Aberrations in the formation or behavior of these cells are the main causes of abnormalities in the head and face. During the first 3 days of development, the fertilized ovum, or egg, is located in the fallopian tube. As it travels down the tube, it undergoes rapid divisions to form a cluster of cells called the morula. These cells then organize themselves to form the blastocyst, and by the end of week 5, the fully formed blastocyst comes into contact with the uterine wall for implantation. During the 2nd week of development, the inside of the blastocyst, known as the embryoblast, becomes 2 layers, the hypoblast and the epiblast layers. Together, these layers form an oval-shaped disc-like structure. In the 3rd week of development, a streak is created on the surface of the epiblast, during which time the cells of the epiblast detach and migrate. These migrating cells create 3 layers, the ectoderm, mesoderm, and endoderm layers, which go on to contribute cells to form all the tissues and organs in the human body. In the 3rd to 4th weeks of development, a cord called the notochord is formed. This induces the cells in the overlying ectoderm to thicken, forming a region called the neural plate along the back of the embryo. The edges of the neural plate elevate to form the neural folds that eventually fuse to form the neural tube. During this process, neural crest cells are formed along the entire length of the tube at the tip of the folding neural folds. Neural crest cells formed from the head or cranial region are called cranial neural crest cells, or CNCCs. These cells multiply and soon start migrating over long distances in distinct paths from the back of the embryo towards the front of the embryo. Once they arrive at their target destinations in the facial regions, CNCCs further develop and mature and ultimately contribute to a substantial amount of the structures in the head and neck region, such as bones, cartilage, and nerves. Growth, migration, and subsequent differentiation of CNCCs are critically important for proper development of the normal structures of the facial region. Soon after the CNCCs reach their final destination, the facial structures begin to take shape externally. By the 4th week of development, the embryo is characterized by 5 facial swellings, the frontonasal prominence, and the paired maxillary and mandibular prominences. These structures are formed in part from the migration and proliferation of the CNCCs from different regions of the neural tube. In a 5-week-old embryo, the nasal placodes, which will go on to become the olfactory system, and the optic placodes, which will become the lenses of the eyes, will form. In addition, the maxillary and mandibular prominences enlarge and grow forward and towards the middle, eventually giving rise to the upper and lower jaws, respectively. In a 6-week-old embryo, the 2 mandibular prominences fuse to form the lower jaw. At this point, the outline of the mouth is visible. In the 7-week-old embryo, the maxillary prominences grow and fuse to form the border of the nostril and the upper lip. Merging of the maxillary and mandibular prominences forms the cheeks and the corners of the mouth. The philtrum of the upper lip and palate are also created at this time. In this flurry of activity in the first 7 weeks after fertilization, the 5 facial prominences give rise to the formation of the forehead and sides of the face, middle and sides of the nose, the philtrum, the upper lip, the palate, and the lower jaw. By the 7th week of human embryonic development, most of the facial structures can be observed. In the next few months of development, the initial cartilaginous skeleton of the face is replaced by bone, and there is an overall increase in shape and size of the different structures of the face. From childhood to adulthood, the face continues to develop through further growth and remodeling.
Notice that pilot initially development in a vertical direction, and only then we'll get horizontal position. So, and now let's talk about physiological types of occlusion. First of all, we need to know that there are different signs of physiological and pathological occlusion, and they are divided into extraoral signs like facial signs, symmetrical and proportionality, and jaw signs, correct harmonious, and intraoral signs, occlusion. So extraoral and intraoral. I like this occlusion. What does it mean, symmetry? Symmetry is a situation when one half of one thing is the same like opposite half. It means that right side of face is the same as left side of face. But we need to know about opposite situation to symmetry, asymmetry. What does it mean, asymmetry? Asymmetry, it is a reduction of proportion between the left and right sides of the face. And this pathology often associated with syndromes which can complicate treatment. Next facial sign, proportionality. Proportionality, it is sign when the upper and lower anterior face heights should be approximately equal. We know, I would like to mention you that we know 4 types of physiological occlusion: orthognathic bite, straight bite, physiological biprognatism, and opistognatic bite. Once again, orthognathic bite, straight bite, physiological biprognatism, and opistognatic bite. And we know 10 characteristics of the orthognatic bite. First characteristic, the upper frontal teeth cover the lower ones by 1/3 length of the lower teeth crowns. The upper frontal teeth cover the lower ones by 1/3 length of the lower teeth crowns. Second characteristic, the tubercle of the upper canine tooth crown is located between the lower canine tooth and the first premolar. The tubercle of the upper canine tooth crown is located between the lower canine and the first premolar. Third characteristic, the central line between the central incisors of the upper and lower jaws is coincides. The central line between the central incisors of the upper and lower jaws is coincides. Fourth one, the mesial buccal tubercle of the upper first molar is located in the transverse sulcus of the similar lower tooth. The mesial buccal cusp of the upper first molar is located in the transverse sulcus of the similar lower tooth. Fifth one, every tooth of the upper jaw has two antagonists, similar and standing behind, except for the lower central incisors and upper wisdom teeth. So every tooth of the upper jaw has two antagonists, similar and standing behind, except for the lower central incisors and upper wisdom teeth. Sixth characteristic, the buccal tubercles of the upper lateral teeth cover the buccal tubercles of the lower ones, and the palatine tubercles of the upper teeth are located between the buccal and lingual tubercles of the lower teeth. Once again, the buccal tubercles of the upper lateral teeth cover the buccal tubercles of the lower ones, and the palatine tubercles of the upper teeth are located between the buccal and lingual tubercles of the lower teeth. Seventh characteristic, the upper dental arc is semi-elliptical. The lower one is parabolic. In temporary occlusion, there is semicircle on both jaws. The upper dental arc is semi-elliptical, the lower parabolic. In temporal occlusion, semicircle. Eighth characteristic, the dental arches of the upper and lower jaws are symmetrical. It means that right and left halves are similar. Upper jaw and lower jaw. The dental arches of the upper and lower jaws are symmetrical. Ninth characteristic of the orthognatic bite. In the state of central occlusion, there is a full occlusive contact between all teeth. except for unerupted ones. And last characteristic of the orthognathic bite: in the state of physiological rest, an interocclusive space varying within 2 mm arises between dental arches. But notice that key word in this definition is physiological. Rest must be physiological, because in case of non-physiological rest, this space can be more than 2 mm. And let's talk about next types of physiological occlusion. Straight bite. What differences between orthognathic bite and straight bite? Please notice, doctors, that a correlation between buccal teeth, premolars and molars, in all types of physiological occlusion is the same, and differences are observed only in frontal area. So, persons with straight bite have straight contacts between upper and lower incisors. Contacts like H to H. And angle between longitudinal axis of upper and lower incisors is more than 140 degrees. Opposite situation, physiological biprognatism. Similar situation. Correlation between upper and lower buccal teeth is the same, but frontal teeth are proclined, tilted forward. But please notice, without spaces, without tremors and diastemas. And interincisor angle is less than 120 degrees. Normal value of this angle is 130 degrees plus minus 10 degrees. It means that this angle from 120 to 140 is normal. Opistognatic bite. What does it mean? It means that molars and premolars have correct the same position, but frontal teeth are tilted backward. But please notice, without crowding and without any pathology. And of course, in that case, interincisor angle will be more than 180 degrees. Or let's mention geometry, more than open angle. And Let's mention about Andrew's 6 keys of occlusion. You know that first key of occlusion, first K of occlusion, is called correct inclination of a long axis buccal teeth, and this angle will be more than 90 degrees. Second K, angulation. Angulation, it is angle between perpendicular line to occlusal plane and a long axis of tooth. They are shown positive angulation. Third K, called torque. It is angle between perpendicular line to occlusal horizontal plane and line passes through the most forward point of crown part. And we know that torque can be positive and negative. And you need to remember that torque of buccal teeth is negative. Fourth K, called rotation. Why this K is very important? Because rotated tooth will take more space in the dental row. If tooth will be rotated, it will take more space in the dental row. Fifth key of occlusion by Andrews. Tight approximal contacts between teeth in dental row without spaces, without tremors and diastemas. And 6K of occlusion by Andrews, Spee curve. You know that normal deepness of this curve is not more than 2 millimeters. And now, let's talk about classification of malocclusion. But firstly, we need to know where do we begin? Why do we need to classify malocclusion? Classification is the morphological description of the dental, skeletal and soft tissue deviations from the norm. And all morphological deviations from the norm can be compiled into a problem list, which is essential for treatment planning. And now let's mention about orientation planes. First, we need to establish planes of reference in order to communicate which dimension our problem lies. You know that in medicine there are three mutually perpendicular planes: sagittal plane, coronal plane, and transversal plane. In medicine in total and in dentistry partially, sagittal plane. It is an imaginary plane that passes longitudinally through the middle of the head and divides it into right and left halves. And this plane used to describe anterior-posterior relationships. Sagittal plane has synonym median plane. Next plane, coronal or tube, longitudinally through the head, perpendicular to the sagittal plane, dividing the head into front and back. Used to describe superior-inferior relationships. And next plane, transversal or horizontal plane. Transverse plane, aka horizontal plane, it is an imaginary plane that passes through the head at right angles to the sagittal and frontal planes, dividing the head into upper and lower halves. Used to describe right to left relationships. And now let's talk about angle classification. In 1890, Edward Angle published the first classification of malocclusion. The classification are based on the relationship of the mesiobuccal cusp of the maxillary first molar and the buccal groove of the mandibular first molar. If this molar relationship exists, then the teeth can align into normal occlusion. But like type of pathological occlusion, Angle proposed described distal occlusion. It is a situation when mesial buccal cusp of the upper first molar is located to front from median groove of lower, transverse groove of lower first molar. And Angle divided distal occlusion or second class of pathology into two subdivisions. Into two divisions. Division 1 and Division 2. You will meet in literature diagnoses like Class 2 Division 1 or Class 2 Division 2. What does it mean? It means that Class 2 Division 1 has distal correlation between upper and lower first molars, but has sagittal gap between frontal teeth. Instead of class 2 division 2, it is situation without sagittal, space. And the opposite situation by angle, progenic or mesial occlusion, or third class of occlusion, of pathological occlusion by angle. It is opposite situation when mesial buccal cusp of upper first molar is located behind transverse groove of lower first molar. Let's talk about advantages and disadvantages of this classification, angle classification. It is nowadays it is the most widespread classification around the world, and I hope you know why. Because it is simple classification, but main disadvantage of this classification, angle classification, describe all pathology only in sagittal plane, but not describe pathology in transverse or horizontal plane, or vertical plane. Because we know pathology like open occlusion, it is pathology in the transverse plane. What does it mean, open occlusion? Open occlusion, it is pathology without contacts between antagonists. Open occlusion can be frontal or distal, but distal open occlusion can be one side or both sides. And opposite situation from open occlusion, deep occlusion. Deep occlusion, it is situation when upper frontal teeth cover lower frontal teeth more than one-third length of crown of lower frontal teeth. And cross bite or cross occlusion, anterior and posterior. What does it mean, cross bite? Cross bite, it means opposite situation to normal correlation between upper and lower frontal teeth, or upper and lower buccal teeth. And first class of pathological occlusion according angle is called neutral occlusion. Please, colleagues, remember that First class of occlusion, it is not normal occlusion. According Edward Engel, first class of occlusion, it is occlusion with normal physiological correlation between first molars. It means that big Q of occlusion is saved, and all pathology is located frontally from first molars, like here. As can you see, molars and premolars have correct relation, but frontal teeth, like tooth number 2-2, has palatal position, tooth number 2-3 has vestibular position. So doctors, thank you very much.